Hello everyone, my name is Yeremia and now I'm going to explain to you about the number 2 on the 003 assignments. Okay, so the problem is a car travels around the curve is y equals to 1 over 3 x power 3, where both x and y are measured in miles, and the maximum of safe speed is on a curved path is inversely proportional to the square root of the curvature at that point. Okay, so the first question is, if a car can safely travel at 30 miles per hour at the point 1,1 over 3, how fast can it safely travel at the point 3 over 2, 9 over 8? And for the B, we have to interpret the geometric significance of curvature in terms of road safety. Okay, so let's just do number A first. So it's 30 miles per hour at the point 1,1 over 3, and then how fast can it safely travel at the point 3 over 2, 9 over 8? Okay, so let's see the formula here. We got the formula of curve is equals to y. Okay, and then for the safe speed, we got this formula, and then if this formula is inversely proportional to the square root of the curvature, so it is the formula, it is 1 over the curvature kx. Okay, so it is, let's just find this derivative until we got the second derivative of f, because we want the second derivative to compute this formula. Okay, this formula. Okay, after we find the derivative of y for the first one, the second one, and the normal one, we put into the kx formula right here, and then we computed this, and we just input the point. So after we got the kx, which is this one, and then we use this formula to input the point A. So we put the point A into this formula, so x becomes 1 and y becomes 1 over 3, but we have no y in here, so we just operate the x, and then we got this, the 2 over 2, the square root 2 over 2, and for the point B, we also input the x and y into the formula, so we got this one. This one. The 192 over 97 square root 97. Okay, so let's put all of this, the square 2, and then the result of point A and point B into the kx formula, which is this one. So we want to find the speed 2 based on the speed 1, so it is just k2 over the k1, the square of k2 over square of k1. Okay, from the problem we are given the v1, or the first speed is 30. Where is it? 30. Wait. Both on measured in mile. Okay. Oh, this one. If a car can safely travel at 30 miles per hour at the point, so this is the first speed, then we want to find what is the safe speed to travel at the point. This one. Okay. So we want to find v2, the second speed, like this one. So we got the first speed is 30 miles per hour, and then we want to find the v2 at the point B. It is x equals to 3 over 2. Why don't we use the y? Because the y here, we got no y in the formula, so we just operate the x. Okay, so as we put it into the formula, it is square root of 30 over v2. Oh, sorry, this should be not a square root. The square root is outside. Okay, that's my fault. It should be around here. Okay, let's just use this. Okay, yes, this is it. Then we operate for v2, and then we just times both side by v2, and then we got this formula. And then from this, I use calculator for this because it's so hard, it's so complex to just count it by hand, and I got the speed. It is 56.3 miles per hour. Okay, so this is the second speed. And for our conclusion in this number, it is this. For the A point, what is the question again? It is how fast can it safely travel at the point 3/2, 9.8. So the safe speed is approximately this one, 56.3 miles per hour at the point B, the 3/2, 9.8. And then for the B question, it is interpret the geometric significance of the curvature in terms of road safety. So in B point here, curvatures mean how sharply a road bends. So if the curvature is high, that means the road is turned sharply. So if the road was not straight or you have to turn sharply, it's harder to control your vehicles, right? And you have to lower your speed in order to get safe. And then for the low curvature, means the road is flatter or more straight. The road is not turning sharply, it is more straight. And it is easier to drive, right? Then you don't have to lower your speed. So the safe speed is more high. Okay, I think that's all for me. Thank you so much.